The A-10 was intended to improve on the performance and firepower of the A-1 Skyraider. The A-10 was designed around 30mm GAU-8 Avenger rotary cannon. Its airframe was designed for durability, with measures such as 1,200 pounds. That becomes 540 kg of the titanium armor to protect the cockpit and aircraft systems, enabling to absorb a significant amount of damage and continue flying. Its short takeoff and landing capability permits operation from airstrips close to the front lines, and its simple design enables maintenance with minimal facilities. The A-10 served in the Gulf War, Operation Desert Storm, the American-led intervention against Iraq's invasion of the Kuwait, where the aircraft distinguished itself. The A-10 also participated in other conflicts such as in Grenada, the Balkans, Afghanistan, Iraq, and against Islamic State in the Middle East. Stay tuned for more information. Hello guys, and welcome to our channel. Please subscribe and like this video, and we love you for it. The A-10A single-seat variant was the only version produced. Though one production airframe was modified into the A-10B twin-seat prototype to test an all-weather night-capable version. In 2005, a program was started to upgrade the remaining A-10A aircraft to the A-10C configuration with modern avionics for use with precision weaponry. The U.S. Air Force had started the F-35 would replace the A-10 as it entered the service, but this remains highly contentious within the USAF and in political circles. With a variety of upgrades and wing replacements, the A-10 service life can be extended to 2040. The service has no planned retirement date as of the June 2017. Post-World War II development of the conventionally armed attack aircraft in the United States had stagnated. Design efforts for tactical aircraft focused on the delivery of the nuclear weapons using the high-speed designs like the F-101 Voodoo and F-105 Thunder Chief. Designs concentrating on the conventional weapons had been largely ignored, leaving their entry into the Vietnam War led by the Korean War era Douglas A-1 Skyraider. While a capable aircraft for its era with a relatively large payload and long loiter time, the propeller-driven design was also relatively slow and vulnerable to ground fire. The U.S. Air Force and Marine Corps lost 266 A-1s in action in Vietnam, largely from small arm fires. The A-1 Skyraider also had poor firepower. The lack of the modern conventional attack capability prompted calls for a specialized attack aircraft. On 7 June 1961, Secretary of Defense McNamara ordered the USAF to develop two tactical aircraft, one for the long-range strike and interdict role, and the other focusing on the firebomber mission. The former became the Tactical Fighter Experimental, or TFX, which emerged as the F-111. While the second was filled by a version of the U.S. Navy's F-4 Phantom II, while the Phantom went on to be one of the most successful fighter designs of the 1960s and proved to be a capable fighter bomber. Its lack of loiter time was a major problem, and to a lesser extent, its poor low-speed performance. It was also expensive to buy and operate, with a flyweight cost of $2 million in FY 1965. That becomes $60.2 million today, and operational costs over $900 per hour. That becomes $7,000 per hour today. After a broad review of its tactical force structure, the U.S. Air Force decided to adopt a low-cost aircraft to supplement the F-4 and F-111. It first focused on the Northrop F-5, which had air-to-air capability. A 1965 cost-effectiveness study shifted the focus from the F-5 to the less expensive LTV A-70, and a contract was awarded. However, this aircraft doubled in cost with demands for an upgrade engine and new avionics. The A-10 has a cantilever low-wing monoplane wing with a wide chord. The aircraft has a superior maneuverability at low speeds and altitude because of its large wing area. high wing aspect ratio, and large ailerons. The wing also allowed short takeoffs and landings, permitting operations from the primitive forward airfields near front lines. The aircraft can loiter for extended periods and operate under 1,000-foot ceiling with 1.5-mile visibility. It typically flies at a relatively low speed of 300 knots, which makes it a better platform for the ground attack role than fast fighter bombers, which often have difficulty targeting small, slow-moving targets. The leading edge of the wing has a honeycomb structure panel construction, providing strength with minimal weight. Similar panels cover the flap shrouds, elevators, rotors, and sections of the fins. The skin panels are integral with the stringers and fabricated using computer-controlled machining, reducing production time and cost. Combat experience has shown that this type of panel is more resistant to damage. The skin is not load-bearing, so damaged skin sections can be easily replaced in the field with makeshift materials if necessary. The ailerons are at the far ends of the wings for greater rolling moment and have two distinguishing features. The ailerons are larger than is typical, almost 50% of the wingspan, providing improved control even at the low speeds. The aileron is also split, making it a deceleron. The A-10 is designed to be refueled, rearmed, and serviced with minimal equipment. Its simple design enables maintenance at forward bases with limited facilities. An unusual feature is that many of the aircraft's parts are interchangeable between the left and the right sides, including the engines, main landing gear, and vertical stabilizers. The sturdy landing gear, low-pressure tires, and large, straight wings allow operation from short, rough strips even with a heavy aircraft ordnance load, allowing the aircraft to operate from damaged air bases, flying from taxiways, or even straight roadway section. Front view of an A-10 showing the 30mm cannon and offset front landing gear. The front landing gear is offset to the aircraft's right to allow placement of the 30mm cannon with its firing barrel along the central line of the aircraft. During ground taxi, the offset front landing gear causes the A-10 to have dissimilar turning radii. Turning to the right on the ground takes less distance than turning left. The wheels of the main landing gear partially protrude from their nacelles when retracted, making gear up belly landings easier to control and less damaging. All landing gear retract forward if hydraulic power is lost. A combination of gravity and aerodynamic drag can lower and lock the gear in place. The A-10 is exceptionally tough, being able to survive direct hits from armor-piercing and high-explosive projectiles up to 23mm. It has double redundant hydraulic flight systems and a mechanical system as a backup if hydraulics are lost. Flight without hydraulic power uses the manual reversion control system. Pitch and yaw control engages automatically. Roll control is pilot selected, and manual reversion mode. The A-10 is sufficiently controllable under favorable conditions to return to base, though control forces are greater than normal. The aircraft is designed to be able to fly with one engine, half of the tail, one elevator, and half a wing is missing. The cockpit and parts of the flight control systems are protected by 1,200 pounds. That becomes 540 kg of the titanium aircraft armor, referred to as bathtub. The armor has been tested to withstand strikes from 23mm cannon fire and some strikes from 57mm rounds. It's made up of titanium plates with thickness varying from 0.5 to 1.5 inches, determined by a study of likely trajectories and deflection angles. The armor make up almost 6% of the aircraft's empty weight. Any interior surface of the tub directly exposed to the pilot is covered by a multi-layer nylon spall shield to protect against shell fragmentation. The front windscreen and canopy are resistant to small arms fire. This A-10, piloted by Captain Ken Campbell, suffered extensive damage during the Operation Iraqi Freedom in 2003, including damage to the hydraulic system, but she flew it safely back to the base on manual reversion mode. The A-10's durability was demonstrated on 7 April 2003 when Captain Kim Campbell, while flying over Baghdad during the 2003 invasions of Iraq, suffered extensive flak damage. Iraqi fire damaged one of her engines and crippled the hydraulic system, requiring the aircraft stabilizer and flight controls to be operated via the manual reversion mode. Despite this damage, Campbell flew the aircraft for nearly an hour and landed safely. The A-10 was intended to fly from the forward air bases and semi-prepared runways with high risk of the foreign object damage to the engines. The unusual location of the General Electric TF-34GE100 turbofan engines decreases ingestion risk and allows the engines to run while the aircraft is serviced and re-armed by the ground crews, reducing turnaround time. The wings are also mounted closer to the ground, simplifying servicing and rearming operations. The heavy engines require strong supports. 4 bolts connect the engine pylon to the airframe. The engine's high 6:1 bypass ratio contributes to a relatively small infrared signature, and their position directs exhaust over the tailplanes, further shielding it from detection by infrared homing surface-to-air missiles. The engine's exhaust nozzles are angled 9 degrees below the horizontal to cancel out the nose-down pitching moment that would otherwise be generated from being mounted above the aircraft's center of the gravity and avoid the need to trim the control surface to prevent pitching. To reduce the likelihood of the damage to the A-10's fuel system, all 4 fuel tanks are located near the aircraft center and are separated from the fuselage. Projectiles would need to penetrate the aircraft skin before reaching a tank's outer skin. Comprised fuel transfer lines self-seal. If damage exceeds a tanker's self-sealing capabilities, check valves prevent fuel flowing into a comprised tank. Most fuel system components are inside the tank so that fuel will not be lost due to component failure. The refueling system is also purged after use. Reticulated polyurethane foam lines both the inner and outer sides of the fuel tanks, retaining debris and restricting fuel spillage in the event of damage. The engines are shielded from the rest of the airframe by firewalls and fire extinguishing equipment. In the event of all 4 main tanks being lost, 2 self-sealing sump tanks contain fuel for 230 miles of flight. Since the A-10 operates extremely close to the enemy positions where it's an easy target for the man-pads, surface-to-air missiles, and enemy fighters, it can carry up to 480 flares, 480 chaff cartridges, which is more than any other fighter, but usually flies with a mix of both. A-10C combat exercise at the Nevada test and training ground against hard targets. Although the A-10 can carry a considerable amount of munitions, its primary built-in weapon is the 30x173mm GAU-8 Avenger auto-cannon, one of the most powerful aircraft cannons ever flown. It fires larger depleted uranium armor-piercing shells. The GAU-8 is a hydraulically driven 7-barreled rotary cannon designed specifically for the anti-tank role with a high rate of fire. The cannon's original design could be switched by the pilot to 100 or 4,200 rounds per minute. This was later changed to a fixated rate of 3,900 rounds per minute. The cannon takes about half a second to reach top speed, so 50 rounds are fired during the first second, 65 or 70 rounds per second thereafter. The gun is accurate enough to place 80% of its shots within a 40-foot, that becomes 12.4 meters diameter circle from a 4,000 feet while in flight. The GAU-8 is optimized for a slant range of 4,000 feet with A-10 and a 30-degree dive. The fuselage of the aircraft is built around the cannon. The GAU-8A is mounted slightly to the port side. The barrel in the firing location is on the starboard side at the 9 o'clock position, so it's aligned with the aircraft's central line. The gun's 5-foot, 11.5-inch ammunition drum can hold up to 1,350 rounds of 30mm ammunition, but generally holds 1,174 rounds. To protect the GAU-8 rounds from enemy fire, armor plates of different thicknesses between the aircraft skin and the drum are designed to detonate income shells. The AGM-65 Maverick air-to-surface missile is a commonly used munition for the A-10, targeting by electro-optical, TV-guided, or infrared. The Maverick allows targeting engagement at much greater ranges than the Cannon, and thus less risk from anti-aircraft systems. During Desert Storm, in the absence of the dedicated forward-looking infrared cameras for the night vision, the Maverick infrared camera was used for night missions as a poor man's FLIR. Other weapons include cluster bombs and hydro rocket pods. The A-10 is equipped to carry GPS and laser-guided bombs, such as the GBU-39 small-diameter bomb, Pei-Wei series bombs, JDAM, WCMD, and glide bomb AGM-154 joint standoff weapon. A-10s usually fly within ALQ-131 ECM pod under one wing and two AIM-9 Sidewinder air-to-air missiles under the other wing for self-defense.